Buenos dias. Welcome to another video. I don't know any more Spanish than that. So today's learning objective is to use ratio notation, including reduction to simplest form. So it's a quick reminder what. Oh, okay. Pen. So a quick reminder what ratio notation is. So remember, ratio notation is you have something like 7 to 8. That's kind of a ratio. We talked about what this is quite a few videos. I think I talked about kind of explicitly what this was in quite a few videos back, so do check that out if you don't really remember what's going on. So ratio notation, you just need to be able to use it. So this means that 7 of whatever on the left is equal to 8 of whatever on the right. That's what this ratio means. So last video we talked about ratio notation in terms of scale diagrams. So we have 1 to 1000. This means for example, 1 cm on the map is equal to 1000 centimeters in the real world. So map, real world. And that's this ratio applies to anything. So say if we have say we have, I don't know, say 5 blue balls, 1, 2, 3, 4, 5 blue balls, and 4 blue balls, 5 red balls, and you're asked to express this as a ratio, you'd say, you'd give this as a ratio of 5 to 4. Because 5 of whatever, in this case red, 5 balls of red basically, and 4 balls is the same as 4 balls of blue. Well, not the same, but that's the ratio between the two. So for every 5 balls, red balls, there's 4 blue balls. That's what this ratio means. So if there was, say, a bag, which this was all contained in, let me use black for a bag. Say this was one big bag, right? So this is what this ratio would be illustrating. For every 5 balls in there, there's 4 blue balls. So we've also got something called when we reduce to simplest form. So when we have something, say a ratio, for example, say 35 to 49. This is saying for every 35, say, red balls, we have 49 blue balls, for example. But you can see that if we divide both sides by 7, we have something like 5 to 7, which is also the same thing as saying for every 5 balls there's 7. For every 5 red balls there's 7 blue balls, which is the same thing as saying this, but this is expressed a bit more simply, because you can divide both sides by 7, and this is the same thing, but you can see why this is simpler, right? Because there's no common factor between them, so you can this is what we call the simplest form. So for the simplest form, we have integers on both sides, but there's no common factor between them. So I can't think of any number by which I could divide both sides and still be left with a whole number. So when it comes to finding the simplest, turning a fraction from this, a ratio from this to this, going to simplest form, you just find common factors on both sides. The same logic applies to a three-way ratio. So let's say it's 8, 48, 54. So, for example, we could say, if this was, say, the ratio between how much money, Bob, Dan, and, I don't know, Joe had. So it's saying for every 18 pounds Bob has, Dan has 48, and Joe has 54. But, you can see how here there's also there's a common factor, so you can turn this into the simplest form. So, you just before what we did here, we divided both sides by the same thing. Here we divide all 3 sides by the same thing, basically. So just pause the video, just think about what common factors all 3 of these numbers have, which you can divide by. Okay, so you can see here the common factor is actually 6. The way I can tell that is, I think you can see 2 is obviously a common factor for all of these. So you can see, because the last number is always even, so that's 2. But then I thought if we divide by 2 we get 18, which is 9, right? And with 9, the only other factor is 3, right? So you see these other numbers are divisible by 3, and the divisibility rule for 3 is if you add the digits, and the number we get is divisible by 3, then the initial number is divisible by 3. So we do 4 plus 8, that's 12. 12 is divisible by 3, so 48 is divisible by 3. 54, 5 plus 4 is 9, so that's divisible by 3. So 54 is divisible by 3. And since it's divisible by 3 and 2, the whole thing is divisible by 6. So we divide everything by 6. 18 by 6 is 3, 48 by 6 is 8, 54 by 6 is 9. So we can turn this into the simplest form here. Here it's obvious that there's no other number that's the simplest, that all 3 have in common, because 3, the only factor there is 3 and 1. So But 8, for example, 8 isn't divisible by 3, so kind of we know this is the simplest form now. So that's how you convert into simplest form, and that's it. That's kind of all there is to it. Quick recap, let me just say this again. Just find the common factor between all the numbers that are involved in the ratio. You could have a ratio, perfectly reasonable to have, say, a ratio of, I don't know, 12 to 17 to 45 to 49 to 58, and that could, you could have quite a large ratio. So, for example, if it was, say, the same examples before, say the money Bob had to Dan, to Joe, to Alice, and everyone else in their friendship group, I guess. You can have a ratio of as many as you want. So again, the same logic applies. You just look at all the numbers, think about what the common factor is, and divide through by that common factor till you're left with kind of they all have to be integers, and kind of there's no other common factor left, and that's the simplest form. So hopefully that all made sense, and I'll see you guys in the next video.